All right, you guys. Wish you were here at school, but even though you are not, don't worry. We still have things you can do at home, so you have your resources. Anyways, we're going to be learning about scatter plots this next unit, more specifically about correlation right now. So I'm going to go through this PowerPoint. You have some notes that you can follow along with that I've also attached. So let me know if you have any questions. I'm going to go kind of fast and kind of skip the discussion pieces just so you can get straight to the activity. So scatter plots in reality, so this is your definition on your notes, is that scatter plots are a graph of set of two variables, your x and y, right? You have your x, you have your y, x-axis, y-axis. Data displays as your ordered pairs, which is your x and your y. That's an ordered pair. Those are your points. Those are your coordinates. It shows how two variables relate to each other by showing how closely the data points fit to a line. And we'll kind of talk about what that is called in the future as well. So in class, we'll be kind of having a conversation about your tables and what this means and how you can plot those. But in reality, right, your years are your x-axis. The number of tornadoes is your y-axis. Okay, so we want to label where these go. So because our years are on top, those are our x-axis, those are our independent variables. We put those on our x-axis. Number of tomatoes or tornadoes, not tomatoes, will go on your y-axis up and down because those are your dependent variables, right? It doesn't matter what year you're looking at. It's completely independent. It's by itself. But the number of tornadoes completely depend on the year you're looking at, right? So that's why we have our x-axis as independent, your y-axis as dependent. So we can go ahead and plot those, and we can put those on your line here. And that's how you plot on a scatter plot. And then do you notice a trend? So if you want to pause the video and kind of look at this, do you see a trend? Do you see a correlation? Do you see a connection between the year and the number of tornadoes, right? So as the years get higher, so from 1950, they had 201, but in 1995, they had 1,234. Why do you think that is? Do you see a trend? Why do you think we are seeing an increase in tornadoes? We can continue this process, right? So let's go to our next slide. Again, these are also in your notes. So scatter plots provide a convenient way to determine whether a correlation exists between two variables. So is there a connection between the year and number of tornadoes, right? Is there a connection between your height and how old you get, okay? Is there a connection between the number of wrinkles you get as you get older, right? Of course, those are all going to have correlations. A positive correlation occurs when both variables increase. So as x increases, your independent variable increases, your y will also increase. A negative correlation occurs when one variable increases. So as your independent variable increases, the year increases, and the other variable decreases. So in that tornado aspect, as the year gets bigger, your x is increasing, your y would be decreasing, so we wouldn't see a connection between the number of tornadoes and the year. And then, of course, if the data points are randomly scattered, there is little or no correlation to our two variables. And let's kind of look at some examples here. This graph right here, this scatter plot, shows a positive correlation because as your x is increasing, your y is also increasing, okay? These are also in your notes. A negative correlation as x increases, your y decreases, right? We can kind of see that as your x goes up and up and up, your y goes down farther. And then, of course, if your points are just kind of scattered throughout the coordinate grid and you don't see any correlation, there's little or no correlation. Means there's no connection between your x and y or your independent variable or your two variables. Okay, so kind of an example would be, do we see a connection between how white your teeth are and the number of days you go to school? No, there's not going to be a correlation between those two aspects, right? Let's keep going. So we have some examples. You can kind of pause and figure these out as you go. But a scatter plot of the data related to characteristics of children from 0 to 18 years old. So match each scatter plot with the appropriate variables studied. So number one, age and height. Is there a correlation between your age and how big you get, right? Well, I'm hoping you're thinking, well, the older you get, the taller you get, so there's going to be a positive correlation to that, right? As your age increases, your height also increases. Age and eye color, no, we're not going to have a correlation between that, right? Age and eye color, there's not going to be any correlation, so that would go here. And then, of course, as you get older, the slower you go in distance, and that would be this pot here. I'm going to pause. You're going to run out of time, so watch the next video.